Okay, so let's do the entry task for 517 or 519, depending on which day you have class. How much power, I'm going to circle what we're looking for, is used when 800 joules of work is done in 5 seconds. So we have work and we have time, and we're looking for power. And so we know that the equation for power is power equals work divided by time. So I'm going to write out my variables, P, W, and T. Power is what we're looking for. That's going to be X watts. Work is given to us, 800 joules. And time is given to us 5 seconds. So just plugging it into this equation, my P is X watts, what I'm looking for. My W is 800 joules of work, and I'm going to divide that by my time of 5 seconds. So I just need to plug it into the calculator. 800 divided by 5 equals 160. And I know that it is a watt, but how did I get a watt? Remember, a watt is a joules per second. A joule over a second is a joules per second, which we call a watt. Okay, so the next one is, what is the force? So now we're looking for force on an object that had 75 joules of work and it moves 5 meters. So we're given work, we're given distance, and we need force. So I'm going to draw my circle over here just so I have that in front of me. So we know our main equation for work is work equals force times distance, but now we're looking for force. So I'm going to cover up F, and I'm left with W, or work, over top of distance. W divided by D. So my equation will be force equals work divided by distance. So I still need my variables. Work, force, and distance are my 3 variables involved in that equation. So I'm going to put what I'm given 75 joules of work and a distance of 5 meters. And I'm looking for force, and that's going to be X newtons. So taking these numbers, plugging them into this equation. So my force is X newtons equals my work on top, which is 75 joules, divided by my distance on bottom, which is 5. And I know that 75 divided by 5 is going to be 15. And how did I get to a newton in a joules over a meter? Well, remember, a joule is a kilograms meters squared per second squared. So a meter can be canceled on the bottom. And then since this is a meter squared, which means it's a meters times a meters, I can cancel the squared, which means I'm left with a kilograms meters per second squared. A kilogram mass, a meters per second squared acceleration, a mass times acceleration is a force, which is a newton. So a kilograms meters per second squared is a newton, and that's how I got that unit. Okay, how much work is done? So I'm looking for work if a 23 kilogram box is lifted 2.5 meters. So I know that in work, I need to have a force times a distance. So work equals force times distance. Well, I still would need all of those variables to solve for work. So let's see what we're given. We're given 2.5 meters, which is a distance. So I have that. But I know a force has to be a newton, and nowhere in here do I see a newton. I do see a kilogram, which is a mass. So I also have to remember that I can use my mass to find the force weight of the box. So remember, the force weight is force weight equals mass times gravity. So I'm given mass, and if I multiply it by gravity, I'll get my force, and then I can plug it in for F here. Since I'm looking for work, it's going to be X joules. So let's do that. Let's take our mass, which is 23 kilograms, and multiply that by our gravity, 9.8 meters per second squared, and find out what that is. So 23 times 9.8 equals 225.4. And remember, that's a force weight, so it's a newton. So I have my force, I have my distance, and now I can find my joules. So X joules Well, work equals force times distance. So I'm just going to continue on the problem. So I already have my force. I'm going to multiply it by my distance. Since it's already in my calculator, I'm just going to go times 2.5, and it's going to equal 563.5. And it's a Newton times a meter, which is a Newton meter, or a Newton meter is a joule. There we go. So that's why it was a two-part problem, because I was giving you something that was not part of the original equation, and you had to solve to get the missing variable of force. Okay, the last one. How much times, now I'm looking for time, does it take a 6,400 Newton car to drive 300 meters using 128,000 watts of power? So again, this is another two-part question. So I'm going to look at my equations that I have, and which one includes time? And the only one I know that includes time is the power equation. So I'm going to put up my circle for power here. That is not a good circle. That's egg shaped. Work goes on top, power and time go on bottom. So I know that time is what my goal is. I need to get time. So I'm going to cover up T and get W divided by P, so I at least know my equation that I'm going to need to get to. I also know that I'm going to need these three variables, power, work, and time. So what am I given? Well, I look here, I am given a power, 128,000 watts of power. Am I given a work? So I'm looking for joules. Nowhere in here do I see joules. I do see a Newton and a meter, which I know makes a joule, so we might have to get to that. And I'm looking for time, and that's going to be X. So let's solve for work. So I need a joule. I'm given a force of the car, so it's force weight, but it's still a force. And I'm also given a distance. Well, we also know that work equals force times distance. So I'm going to use this equation to get work. So 6,400 newtons times the distance it travels, 300 meters, equals, type it in my calculator, 6,400 divided by times 300 meters. It's going to give me 1,920,000. And since this is a work, it's going to be joules. All right, so now I have a power, I have a work, I'm going to find time. Remember, it's work divided by power. So time equals work divided by power. Well, here's my work. I'm going to divide that by power, which is 128,000 watts. So I could do cross out and just divide, but I already have this in my calculator. So I'm just going to divide by saying divide 128,000. I get 15. Now, we need a second, which is time. So how do I get from a joules over a watt to just a second by itself? Well, let's break it down a little bit. We know we can break down a joule into a kilograms meter squared per second squared, but let's break down a watt first. We know a watt is a joules per second. Well, right there, I don't even need to break the joules down, because since I have a joule on top and a joule on bottom, they just cancel. What's left? Second, which is what we need. And that is it.